Okay, everyone, we're now attempting to record on a MacBook Pro. I've got the screen set to 1024 by 720. What we're mostly trying to figure out is how YouTube deals with different sizes as you send them up. So I'm recording, and what I'm going to do so I don't just waste the recording session, I'm going to take you into probably the single most important thing about a Mac, and that is that it has on it grapher. Now I want to point out that pacifict.com has the original Apple grapher. This is not the original Apple grapher, but it does lots of cool stuff. And specifically what I want to talk about here is first two-dimensional parametric equations. And so a parametric equation looks like that. I'm erasing here. Parametric equation looks like x and y. Looks like actually basically vectors, and it might look like something like this: equals 3 and 6 is not a parametric equation. When we graph that, you see that it's not showing up on here. I'm going to go view, zoom out, and you've got a point there, view, zoom out. So a really nice way. Now if we actually go something like this, equation, new equation, we're going to set the parameter, which is time, equals 0, which is not going to show up, of course, anywhere. But now here, all of a sudden, when we say this looks like that, you get nothing until you go here, and then so equation animate parameter will go from t equals 0 to t equals 10. We'll hit OK, and we'll turn on and you'll see that thing moving off in space. So parametric equations are basically x and y, or some set of states or variables are parameterized by something t. So the way that most comes up is like this. Typically we'll go ahead and remove the t there. Where this is introduced for the most part in a math classroom is you parameterize it. The simplest way is by putting t being the x parameter and t squared, and I'm hitting being the y parameter. This would graph a parabola. Now when you see something like that, you can see it travel. It's kind of hard to see. Once again, view, zoom out, view, zoom out. All of this is quite possible on a TI-83 calculator. As we look at there, we realize that all of a sudden this gets a lot more interesting. If we do, I can do star there, I think it will take that, and it that's more or less how it's moving out and about. So, and then it also, if you want to see what it looks like, you can then put a comma, t equals 0, or in this case, minus 10 to 10, and if dot dot dot, I think is what it comes, dot 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 or dot dot to 10. So you've got that. Now as you extend the time, you extend out the shape as you go through. So parametric equations, just to show you that's the 2D manifestation of it. Then realistically realizing the kids are living in a 3D world by teaching them playing around with parametric equations where something is parameterized over t, you can have a lot of fun stuff going on in a classroom very quickly. This is not promoted, it would appear, in the Common Core, though I presume it is there. It generally is promoted in any TI-83 calculator, or anytime you start dealing with animation where what's on the screen is going to be changed based on time. That's the animation. So the next thing you can do, of course, is you can go File, New, again recording, go to a 3D graph, I'll do the most simple one here, and I'll just start with the typical time equals 0. That's our first equation, new equation, and basically I'll do it 1x plus 2y plus 3z equals 1, and you'll get a plane there. But now if I do 1t, we also get the same plane, but then over here now I go ahead and right away students can kind of understand, well, that's kind of looks pretty similar to x plus y equals something, and maybe that was like a line, and it's a pretty logical jump to make it to be a plain. You can parameterize some things in here, but the first thing you're going to just parameterize is that t over here. And what you're going to do is once again go to equation, animate parameter, animating the t. We're going to go from 0 to, once again, I guess to 10. Very quickly, students can start to get some intuition that math is a little bit more fun, both in 2D and 3D, than might be laid out. This program is available, and I would tell you, just because you don't have a Mac does not mean you don't have access to this. For $20 for students for a year, $60 for students forever, and $100 for non-students. The backstory on this is worth it just itself, on the story of its creator and how this came to be. So I am now, hopefully, this has been recording, but I don't see the record button up above here. So I'm guessing it didn't record, and I'm going to be kind of mad. But, oh, there it is. Stop recording. And now I'm going to post this out to YouTube and see mostly what it does with the size of the screen recording, which was recorded by setting the screen to 1024 by 720, with 720 being the controlling thing, I think, on YouTube.